Lesson 5.12 is about rate of change. This is the final lesson for Unit 5 here. We're in your notes packet on page number 22. The rate of change for a graph describes how a graph changes. In this case, the graph does not have to be a proportional graph. So we're going to be looking at graphs that are lines. So they are going to be a linear relationship. So they're going to be a line, but they do not have to go through the origin. If they do go through the origin, we can actually look at the rate of change, but the rate of change in that case is just going to be our K value, our crazy K, our unit rate. So for these examples, the ones that we're going to look at primarily are not necessarily, when we look at a graph, going to be proportional ones that go through 0, 0, but they'll still have a rate of change. The rate of change for a line can be positive or negative. So if we're looking at a graph, a line going upwards as you go from left to right is going to be considered a positive rate of change. When we're looking at a graph and we have a line going downward, that's going to be a negative rate of change. This is our formula here for rate of change, and it's very similar to what we saw with K. When we had the K value, we just simply did a Y value divided by an X value. In order to find the rate of change, we actually need to have two values because we are finding what's called delta. Delta is a Greek letter, and in math, delta represents change. So what we're seeing here for our rate of change is we're looking at how are the Y values changing over how are the X values changing. So we would need at least 2 points that are on our line to be able to make a comparison, or 2 parts that actually show up in a chart for us. We're going to get started with number 1. The table shows the amount of money a booster club makes washing cars for a fundraiser. Use the information to find the constant rate of change in dollars per car. Keeping in mind when we look at a table, on the left side is your X and the right side is your Y. So when I go from 5 to 10, you'll notice that they put in a plus 5 for us. 10 to 15, we added another 5, and 15 to 20, we added another 5. So it looks like all these X values are going up by 5s. When we look at the Y values, it looks like they're going up by 40s. So our rate of change is going to look at these change values. This is our change in Y, and this is our change in X. So anytime we take a look at one kind of grouping here, we can compare the change in Y, 40, to the change in X, 5. So in this case, 40 divided by 5 is 8. Our rate of change here is actually a positive 8. This is going to be a single value, just like our K value was in the last couple lessons. Our rate still tells us the Y, the dollars, per the X, which is the number of cars. So in this case, with the rate of change being 8, it tells me it's $8 per car. And since I actually divided, that would be per 1 car washed. For number 2, we have Sam's savings account. In months, we have those listed across the top here and our money saved. Since this isn't labeled, we're going to label the top X and the bottom Y. We're going to look at the X's. From 1 to 2, this went up by 1. From 2 to 3, this went up by 1. And from 3 to 4, this also went up by 1. When we go from 85 to 95 down here, this went up by 10. 95 to 105 went up by 10. And 105 to 115 also went up by 10. So our Y value is changing by a positive 10, and our X value is changing by a positive 1. So 10 divided by 1 is just 10. The rate tells us the Y divided by the X. So my Y label is the money saved per month. So that tells me for Sam that Sam is actually saving $10 per month. This was one that we actually had in our lesson yesterday where we looked at the baby's growth. We didn't have any points on the line, but today we actually do. So we're going to look, keeping in mind this is your X and this is your Y. As I go from 4 to 8, I'm increasing by 4. 8 to 12, I'm increasing by 4. 12 to 16, I'm increasing by 4. That's my delta X part. Down here with the Y's, 21 to 22, I'm increasing by 1. 22 to 23, I'm increasing by 1. And 23 to 24, I'm also increasing by 1. These are the changes in my y values because I'm looking at the y part of my coordinates. So when I find my rate of change, I'm going to do delta y, which is 1, over delta x, which is 4. So my rate of change here is just 1/4, or I could write this as 0.25. The rate, remember, is just the y's per the x. So our y value is the length in inches per my x label is growth period in months. So we're looking at how many inches per month is the baby growing. So this baby is growing at a rate of 1/4 of an inch or 0.25 inches per month. So rate of change is very similar to what we were seeing with our K value, except for that we can use rate of change to describe change in a graph that is not necessarily proportional.